Hello everyone, I'm Anita from PinCap Performance Testing Team. Today I will present some real-life case studies based on the Performance Overview dashboard. The theme of this sharing section is called Looking Outside the Database Before Turning Database. When it comes to database performance tuning, it's easy to fall into the trap of only looking within the database itself. However, sometimes the root cause of performance issues lies outside of the database entirely. During many POC processes, we often face questions from the customers. For example, the user A may ask, "We have enough client resources, so why is the response time so slow?" It must be due to the slow database. Meanwhile, the user B may inquire, "There are many idle resources on the load balancer, so why is the response time so slow?" Database must be the bottleneck. So, where has the time gone? Does the bottleneck really lie within our database? To ensure we are all clear on the concept, let's refresh our understanding of the definition of user response time and then answer the question, where has the time gone? For different people, user response time has different meanings. For DBA, it maybe means query durations of SQL processing in the database. For users, response time includes the time it takes for a request to be initiated from the client side, sent via the network to the application side, forwarded by the application side to the database, processed by the database, and the result returned to the application side. Finally, the application side sends the result back to the client side. So, in fact, there are many factors that can impact database performance. Therefore, before diving headfirst into tricking database settings, it's essential to take a step back and look at the bigger picture. By examining the system as a whole, you can gain a better understanding of the factors that are impacting database performance and make a more informed decision about how to optimize it. In this way, looking outside database before turning the database can lead to more effective and efficient performance improvements. Next, here is the source of performance improvement. What does that mean? The picture on the left shows the percentage of the expected performance benefits from different sources that we image. Developers often habitually believe that performance optimization should start with optimizing the database internally or starting with the basic framework. However, in multiple POC processes, we found that approximately half of the performance benefits come from outside the database, such as the application architecture, deployment methods, and coding practice, and so on. Subsequently, I will use two practical cases to illustrate why we advocate for looking outside of the database before turning the database. From the monitoring, we can see that the TiDB average latency is about 6.56 milliseconds, and the connection idle duration is about 20.7 milliseconds. Have you noticed that the connection idle duration is significantly higher than the TiDB average latency? This observation suggests that the current bottleneck may be located outside of the database. So why do we determine that the bottleneck is outside database? Because we found that the customers application is in London and the TiDB cluster is in Frankfurt. This distance between London and Frankfurt is about 770 kilometers. The network latency between them is also one of the main causes of the performance bottlenecks. Another case is from the customer B. From the monitoring, we can see that the QPS is about 10,000 and the TiDB average latency is about 6.03 milliseconds and the connection idle duration is 19 milliseconds. Yes, the behind the phenomenon is similar to the customer A. During the communication with the customer, we obtain some key information about the testing approach. Customer B's situation is to use one JVM client to launch 250 concurrent operations, which is very resource intensive. It is generally not recommended that the total number of concurrency of a JVM exceeds 200. If you want to get better performance, it's recommended to split into multiple JVM clients. After splitting 250 concurrently into 10 JVM clients, you can see the QPS is increased from 10,000 to 31,000. The TiDB average latency remain almost constant, and the connection idle duration, we can find that it's dropped from 19 milliseconds to 1.22 milliseconds. As I mentioned earlier, simply by modifying the way the application is used without making any changes to the database, we can achieve a threefold increase in performance. This is a highly cost-effective solution. Besides the two practical cases I just shared, what are some other performance issues that could be outside the database, such as the client or server is under-provisioned without enough resource? HA proxy is used as a TiDB cloud proxy, but HA proxy CPU resources are insufficient. HA proxy is used as a proxy for the TiDB cluster, but the HA proxy server is under high networking load. The latency from the application server to the database is too high. For example, the application server and the TiDB cluster are not in the same public cloud region. The client program has bottlenecks and cannot make full use of the server's multiple CPU cores or NUMA resources. For example, the application only uses one JVM to establish thousands of JDBC connections to the TiDB. Based on the sharing just now, we should now be able to make a simple assessment of how to locate the bottleneck. When we receiving some monitoring data, we can first focus on two indicators in the performance overview dashboard, such as duration panel and the connection idle duration panel. The duration panel contains 99 delays for all statements and the average latency for each circle type. The connection idle duration panel contains the average and the 99 delays for an idle connection and the two states when the connection is idle. One is in transaction, represents the idle time of a connection in a transaction. That is the time between processing the previous circle statement and the next circle statement while the connection idle is in a transaction. Not in transaction. The time interval between processing the previous circle statement and the next circle statement when the connection is not in a transaction. Have you found that when
Average in transaction, average not in transaction,
of connection idle duration is much higher than the TiDB duration? Maybe you can say that the bottleneck is outside the TiDB. Okay, that's all for today's sharing. Thank you.
If you want to learn more, scan this barcode and then you can get access to more PinCap training and certification resources.